So on to a new unit. Today we're talking about analyzing results by using measures of center and variability. We'll talk about what those measures of center mean and measures of variability mean to judge overall performance. It's very much like a data kind of unit, and obviously we're only going to get like 4 lessons into it. But it's pretty neat. It's stuff that you get bombarded with data because our world now collects more data than we ever have. And they use data to manipulate you, to make you believe certain things. And so understanding what these kinds of terms are, mean, median, range, as well as absolute deviation, can be really important in you making a better judgment about the kind of data you're looking at. Patrick?
Are we going to learn about this in 8th grade?
Some, yes. Yep. We're just touching on it. Giving you a little foundation before 8th grade.
What about the population part?
Yeah.
We won't get into that, but you will do that in 8th grade.
Is that like the lineup population kind of?
No. It just looks at how data sets and how means get applied to populations for different populations. So there's a lot of, for instance, like when you look at politically, when you have so many registered Republicans and so many registered Democrats, what they'll do is they'll take averages of how those people vote across the country, and then they'll apply those averages to Salida. And they'll say, oh, there's this many Republicans, we can expect this many people to vote.
There's more Republicans
Okay.
than Democrats in Salida.
Well, it's not about who has more, who has less. What they do is they use the information to better inform their constituents around what will happen and what they think will happen.
Is that what we're doing?
No, we're on the very bottom level of that. But that's looking at how they use this stuff in real life. Voting populations is a big place where you see a lot of data sets that get manipulated and then spit out. Yeah.
What does it matter if you're like a Republican or a Democrat?
We're not having the Republican Democrat
You
conversation.
But like, you can vote for either party still.
You can vote for any party. So, but that goes back to that conversation. What I was saying is that they use this information to better estimate how many Republicans are going to vote, and then how many Republicans are going to vote Republican, how many Democrats are going to vote, how many Democrats are going to vote Democrat, or vice versa. And so what they do is they use that information across the country, and they have years and years and years of data and elections, and then they apply it to the next election, assuming that it's going to be fairly similar. And it comes out amazingly accurate. So, mean. What's mean? What we got? M.
The average of like a set of data.
So I have a data set, right? And then, so if I have a data set where, let's say it's 8, 6, 14, 20, 30, 5, and 16. That's our data set. The mean would be to take
All of them added together and dividing it by the number
Of numbers.
Yes. I take all of them, I add them together, I figure out how many I have, how many values I have. 1, 2, 3, 4, 5, 6, 7. I would divide that by 7, and that's going to give me my average, my mean. Median. Who knows what median is? Clarky. Median.
The number that marks the midpoint of an ordered set of data.
So that's the key right there. It's an ordered set of data. It's usually ascending. Ascending means from smaller to larger. Okay, so if I took my data set, ascending would be 6. Whoops. Already messed up there. 5, 6, 8, 14, 16, 20, 30. That would be my ordered set. And it's in ascending order, smallest to biggest. And now what I do is I basically take one off from each end. I'm finding the physical midpoint. Okay? There, one there, and then one here.
What do you do when it's needed? Don't you find
Aha, yes, I was just going to do that. So let's say our data set looks like this. There's a 33 on the end. So now I get to the middle and I have two numbers. What I do is I take those two numbers, I add them together, divide by 2. Now here, I don't have to add them together and divide by 2. You know what's in between 14, 16, 15. So my median here would be 15, but sometimes you'll have a data set that, will be 320, and then this is 780, and you're like, I have no idea. Well, you take 320, 780, add them together, divide by 2. 550.
Yeah, I wish I could do that.
So,
God, that'd be so fun. I want to go around and be like, oh, that's 540. Right?
I can only do it with certain numbers, John.
Just the human
That'd be so
calculator.
cool just to know that.
All right, so that is how. So the thing you need to understand is that it's in order, can be ascending, could be descending, which is biggest to smallest, and it is literally the physical middle. It's like what number's in the middle. If I have one number, it's that number. If I have two, add them together, divide by 2, it's that number. So that's a good example. Range. What's range? My range, this is a good one, for this data set right here would be 33 is my biggest, my smallest is 5, I go 33 minus 5, that's my range, 28. It is my largest minus my smallest. It's telling me how far are my largest and smallest number apart. What's the value in between those two? That's a good question. What can you do? No. Why or how can you use the range in a problem? Good one. Voting population. So I could, and I'm going back to voting. Gosh, man.
What is a width?
Get off this bandwagon, huh? So let's say, let's do something totally
Do you
different.
know what bandwagon means?
Yeah?
Okay.
So here, Patrick, let's say I am a donut maker, and I want to open up some donut shops. Krispy Kreme. I want to open up a you're like Krispy Kreme in Salida at 444 West First Street, because that's where I live. I'd like instant, no. Oh my gosh. Preston's like, okay. He's gonna be all like, I heard there's a Krispy Kreme here.
Yeah. Like I ordered, I called in.
So I'm looking at places to build a Krispy Kreme. And so I could use my range. This might not be 100% true, but I could use my range of population of people that are employed, and I could use that range to then see, is this a population that I want to sell Krispy Kremes in?
Why don't you just like,
everybody wants Krispy?
Pretty much. That's why I said it's not a great example, but it made you listen.
Right. I can
You heard Krispy Kreme and was like, what?
Yeah. It's like, here we go with the vote. Krispy Kreme?
So, range will tell you, like, out of the population in Salida, what's the span of people that buy donuts from Safeway? Or, so that's the information that you can use a range for. You can be like, oh, people that range from, 14 to 48. And so, are they going to try to advertise to older people? No, they're not going to. They're going to focus their advertising on the range, right?
If you make the donuts not
So
possible.
car sales, there's a way better example. They use range all the time. because they use it for like, what's the population that buy Dodge Durangos, right? And then they'll put them out there, and then they'll say, oh, so maybe we don't want to advertise during, this event because that's a younger crowd. We want to advertise during the Pro Golf Tour, during the Augusta Championship or something, right? Where the viewer population's older. So they take that range and they're like, wow, we're going to use that to help us advertise.
So like if they're going to advertise to old people, they're going to do it where they
find more, exactly, a higher population of older people. So this here, I'm telling you, this is some of the most useful stuff as a business person. If you open up your own business, you'll use mean, you'll use median, you'll use range to help you pinpoint customers, to help you figure out what's best to put on the shelves. If you have like a soft goods place where you're selling soft goods or something. This one, mean absolute deviation. This is one, I just used this to help put together our Algebra 1 class. When you take maps, you're given a hard score. You get to see your hard score, which is like, I scored a 234. And so you'll see the 234. I see mean absolute deviation. I see something different. It will say 234 to 238
Can you give an example?
to, I am, 228. Whoops, 230. So this right here has a mean deviation of 4, plus or minus 4. You scored a 234. But then I see your mean deviation, which tells me if you were to take this test again, based on their data, on how you answered the questions, and remember, they have over like 9 million kids take MAPS tests globally every year. So their data pool is massive, and they are super accurate.
And doesn't every state do maps?
Not every, but a lot. And so they'll give me this mean absolute deviation score. And that means if Emma was to take this test again, she got a 234 the first time. If she was to take it again a week later, they're saying within, not certainty, okay, but very close, they can predict this is where she will probably score. Okay? If she was to do it again. And it's because of that plus or minus deviation of 4. Because they have kids who take it over again. And they see your growth. And they use all that information to figure out like, oh, that's probably what she'll get again.
We're scared to take math tests every week.
What?
I wouldn't be teaching because that would be awful. I could not do maps. I
wouldn't be
can't.
going to
I
school.
like doing what I'm
That would be
doing now. This is exciting teaching you guys because you listen and you work hard for the most part. Preston works hard on remembering where I live. So, because he's like, you're going to give me that A.
Wasn't it something west?
He's going to be knocking on every 444 on the west side. He'd be like,
Krispy Kreme!
No, it's west.
Just running down the street.
It's west.
all right. So this, hey guys, this mean absolute deviation is your averages and how far your tests are off the average. And I'm going to explain more about it in a little bit. I know it sounds very complicated, but it's not as complicated as.
Let me go back and look at this video. Is your actor still in it?
I don't know.
It's recording.
Any questions about this? Okay, moving on to the next thing, which is, let me erase all that. Here we go. Got a number of things to take care of in about less than 5 minutes or a little bit more. It's actually, I'll give you like 10 minutes. So you're going to, we already did your math books. You're going to switch your warm-up and exit ticket with your partner from last week, your table partner. If you don't have a table partner, then you find someone close to you who doesn't have one as well. Whoa, don't do that yet. Just wait, because I want to go through this. Rubrics. You grabbed the rubric when you walked in. Use the rubric to score. You've done this many times. I have, Tristan, Shannon, I have exemplars here. I have exemplars here. I have 2 different exemplars over there, warm up and exit. Use them to give you an idea of what a 16 should look like. Okay, so it will give you an idea, be like, whoa, is that even what we were supposed to do? Come over, look at it. You can look at it and you can say, oh no, that's going to be 2 points off based on the rubric, or whatever, 1 point off. That's the first thing. Second, you may recycle your old classwork and index. Okay? Don't crumple it up, just put it in flat, because we're going to run out of space. Now, my suggestion. Now, if you don't owe me any warm-up and exit tickets, Emma, go for it. But there's been people that recycled, and then they owed me warm-up and exit tickets, and then I was like, you got to do it again. So you can recycle as much as you want if you're willing to do it again. I can give you some information pretty quick on whether or not you owe something. I'm going to, guys, whoa, can we just wait? Please. Bosenko. Okay. If you're not sure about how you did on the last unit, don't worry about recycling this unit, because I will give you a review sheet for your retake if you need to take a retake. Grab a new piece of paper and make a new index. We did that one. We got 3 things to do. We got 10 minutes to do it. Go. Boom. Bind them. Thank you.